This was much darker than I gave it credit for being. Unfortunately, it was kind of near the limb, near the edge of the Earth from our view, so several 100 miles away. But it still was impressive to be able to see that dark spot as we passed by.
People ask me how long have I been waiting for this particular eclipse? Almost 20 years.
We actually just took our kids out of school. Today was my oldest daughter's first day of school, and we just said, you know what? It's worth it.
I tell people it's kind of like a Woodstock on a mild level.
Mostly fun and scary at the same time. I'm very excited about it.
This is one of the most remarkable experiences you can ever have in your life. You'll never forget it.
We have a tiny sliver left. We are almost to totality. There are clouds all over the sky, except for where the sun is.
Woo! We are looking on a west from the BBC World Service at totality.
Oh my God, I am shaking. It is incredible. I have never seen something like this.
Everyone here has been overjoyed and excited for this. You can hear them screaming.
We've stopped looking at the sun, and it's kind of like everyone around us, the thousands of people, it's quiet, but they're starting to look at each other. Everyone's kind of looking around thinking, what was that? Did we just see that? Did that really just happen?
Wow, look at that. That is the moment you were talking about the corona earlier. You get these final few seconds, don't you, where you get just the edge. It's almost like a diamond ring.
Yeah, yeah. This is absolutely amazing. And
where thousands of people are gathered and experiencing this monumental event, a total solar eclipse. Let's take a look and take in the view.
That's so pretty.
This is completely different than anything I've seen before. I never saw an eclipse. I've seen a partial, but nothing like this. This is really unique and nothing like I saw in space. Space has this really cool visuals, but this is really amazing.
You know, and I'm starting to hear the crickets. They're starting to come on out. Obviously, the street lamps. This is just amazing. Now, I'm also looking up to try to find the Big Dipper and some of the other stars, some of the other planets.
Not for the clouds, likely.
Right.
And I'm like I'm really mesmerized by this. This is a spectacular event. We've had several solar storms that have been launched, and some of them have been launched from the left side of the sun. So we're actually seeing a difference from what the corona looked like in our predictions to what it looks like now.
Walkthroughs. Time to go to walkthroughs. Debo, where you going? We got walkthroughs. Time to go. Time to go to walkthroughs.
We're still. I don't think we're quite there yet.
Oh! It's like nighttime.
Wow, my phone just glitched. My phone just glitched.
Woo! Dude, it's so dark. It's so dark. Whoa!
Take them off.
Woo! Woo! Wow. That's crazy. That's crazy.
Look at their stars, guys. Look to the right. You can see stars.
My phone died.
crowd that's building here.
And now we've got that G3 aircraft, the one we talked about earlier. It's ready. They're 35,000 feet up and ready for us. We have an exclusive feed as they fly over the Pacific Ocean. Kevin Rohr from NASA's Armstrong Flight Research Center is standing by. Kevin.
She's pausing. Hi, welcome aboard. We're on NASA Armstrong's G3 aircraft right above the Pacific coast. I'm Kevin Rohr, and I'll be your host on the aircraft. And a big howdy, and thanks to everybody on the ground that's making this shot happen. We've got a fantastic look out the window right now. We're circling above Lincoln City. We got a little bit of cloud cover down there, but we're going to have a fantastic view of the eclipse, and this should prove to be a wonderful day. With me today is Robert Lightfoot, Administrator of NASA, as well as Dr. Zabukin, Head of Science. And what we're going to do is cut to them really quickly so we can have a little discussion. And what are your impressions today, Robert?
Thanks, Kevin. What a great morning so far over the Pacific Ocean. We got to see the first bites out of the sun from the moon. Just an incredible view so far. I really want to thank all the teams that are out there all over the country helping us to get the science, the most science we can get from here. Really going to be an inspirational day and hopefully inspire the next generation of scientists, engineers like me even in the current generation. Pretty inspirational from that standpoint. Volunteers everywhere, so we're excited about what's going on. And you know, I got to turn it over to my buddy Thomas here. This is his field of study. So Thomas, what do you think so far?
Oh, it's amazing. We're already seeing it happening, right? Why do you think this is important to NASA and the United States?
Well, for us, it's a great opportunity. The totality across the continent, we're going to learn as much as we can. We study heliophysics and astrophysics in NASA, and this is a great opportunity for us to learn even more and have every instrument we have out there available to us to try to understand what we're going to see for the first time in 99 years. So just very, very exciting to see what we can do here and the observations that we're going to get. Can't wait to see the science come in and all the different science we're going to get from here. So, you know, everybody's going to learn something. So you tell me what you think you're going to learn, Thomas, having been studying this for your whole career.
Well, look, my field of study is the sun. And what's really unique about this time is the opportunity to see the solar corona, the atmosphere of the sun, during the entire time of the eclipse stitched together for 1.5 hours. And the sun, of course, is important because it's the most important star. Everything we learn about other stars we learn here first. But it's also a source of weather and radiation. And actually on board this aircraft we have two instruments, one from Los Alamos and one from Space Environment Technologies, that make those very measurements of how this radiation affects us.
Yeah, and I think it's important. The more we know about the sun, the more we know about space weather, it'll help us protect our own spacecraft in the future. It'll also help us protect our astronauts as we send crew further, and our home planet in terms of what's going on here. So why don't you tell me what you think we're going to see today and what we're going to learn today through this just incredible event.
So one of the most amazing parts of this is really to see the star as a magnetic star. And what I'm showing here is actually a prediction of the space environment of the sun today by predictive sciences and 3D printed by Applied Physics Lab. And it basically shows that these magnetic fields are there. And what's really going to be great today is we're able to test these models using observations from the ground that we normally don't have. And so this is really exciting for us.
Very good. We've got over 11 spacecraft and over 50 balloons going up. We've got airborne science like we're even doing here on the G3. Can you explain what we expect to get out of the spectrograph we're going to have here on the plane today?
So a spectrograph is basically taking the light of the sun, which is white, and spreads it into its colors. And what we're going to see is during the time of now and partial totality, we basically see during the partial eclipse, we see the radiation from the surface of the sun, the photosphere, and all colors are there. Well, when we're in total eclipse, what we're going to see is the radiation from the atmosphere that we normally really don't see that up close. And that radiation actually has two predominant lines. One is really hot iron, and the other one is, it's hot because it's 1,000,000 degrees because of that magnetic field. The other one is helium, called helium because of Helios, the sun in Greek. So it was actually discovered during an eclipse, just like it today.
Very cool. So here we are, about 30 minutes away from totality. But you can explain to me what you think from a spectrograph perspective. You're going to look out the window. What are you going to see there?
Well, so for me, the amazing part really is that we're able to, of course, see our star in its beauty. And I'm already kind of emotionally touched even now. But also, we're going to see how that eclipse, that the lack of radiation, this perfect cloud that the moon makes affects the Earth and its turbulence. I mean, I'm really going to see whether we're going to feel it up here.
Very cool. All right, thanks, Thomas, and thanks for sharing everybody out there. I tell you, about 30 minutes away, we're going to measure as much as we can here, and I'm about to fight this man for a window seat. So when you get on an airplane and you look for a window seat, get your glasses on. We're going to look out here, and we're going to wrap up here from the G3 and send it back to